Our universe is a place of incredible vastness and wonder. It's filled with objects that defy our imagination. Among these celestial giants, stars hold a particular fascination. They are the cosmic engines that illuminate the universe. And some stars, like Ui Scuti, push the boundaries of our understanding. Ui Scuti is a star of truly gargantuan proportions, a behemoth that dwarfs our own sun. Its discovery has sent ripples through the scientific community, forcing us to re-evaluate our understanding of the cosmos and the sheer scale of the universe we inhabit. Ui Scuti is a pulsating variable star. This means its brightness fluctuates over time. It belongs to a rare class of stars known as red supergiants. These stars are in the later stages of their life cycle. They have expanded significantly, becoming incredibly large and luminous. In this essay, we'll delve into the fascinating world of Ui Scuti. We'll explore its size, its properties, and what its existence tells us about the universe around us. To truly grasp the immensity of Ui Scuti, we need to compare it to something familiar: our own sun. The sun, a star we often perceive as vast and powerful, is dwarfed by Ui Scuti in every way imaginable. If we were to replace the sun with Ui Scuti, its outer layers would extend beyond the orbit of Jupiter. This means that Earth, along with Mars and the asteroid belt, would be engulfed by the star. The diameter of Ui Scuti is estimated to be around 1,700 times larger than the sun's. Its volume is so vast that it could hold roughly 5 billion suns. To put this into perspective, imagine trying to fill Ui Scuti with grains of sand. Even if you could somehow gather all the sand on Earth's beaches, deserts, and seabeds, it would only be a tiny fraction of what's needed. Measuring the size of a star that's thousands of light years away might seem like an impossible task. After all, we can't just stretch a measuring tape across the cosmos. However, astronomers have developed ingenious methods to determine the dimensions of these distant celestial objects. One of the primary methods used is called interferometry. This technique involves combining the light from multiple telescopes to create a virtual telescope with much higher resolution. By analyzing the interference patterns created when the light waves from these telescopes interact, astronomers can calculate the angular diameter of a star. This angular diameter is a measure of how large the star appears in the sky. It's similar to how we might describe the size of an object held at arm's length. To convert this angular diameter into an actual physical size, astronomers need to know the distance to the star. Thankfully, advancements in astrometry, the science of measuring the positions and movements of stars, have allowed us to determine these distances with increasing accuracy. Ui Scuti is not just large, it's a star of extremes in many other ways. Its estimated volume is a staggering 5 billion times that of our sun. If we could somehow transport ourselves to Ui Scuti and stand on its hypothetical surface, we'd experience gravity far weaker than what we feel on Earth. This is because even though Ui Scuti is much more massive than the sun, its mass is spread out over an incredibly large volume. Despite its enormous size, Ui Scuti is surprisingly lightweight for a star of its kind. This is because it's constantly shedding its outer layers, creating a vast diffuse envelope of gas and dust around it. The temperature of Ui Scuti is estimated to be around 3,365 degrees Celsius, which is much cooler than our sun. This cooler temperature is what gives Ui Scuti its reddish hue. Section 5. A fleeting giant, Ui Scuti's eventual fate. Despite its immense size and power, Ui Scuti is not immortal. In fact, it's nearing the end of its stellar life. Stars like Ui Scuti live fast and die young. They burn through their nuclear fuel much more quickly than smaller, less massive stars. Astronomers estimate that Ui Scuti is only a few million years old. This might seem like a long time, but it's a blink of an eye in cosmic terms. When Ui Scuti finally exhausts its nuclear fuel, it will no longer be able to support its own weight. The core of the star will collapse in on itself, triggering a cataclysmic supernova explosion. This explosion will be so bright that it will briefly outshine the combined light of all the other stars in its galaxy. The remnants of Ui Scuti's core will likely form a neutron star or a black hole, objects of incredible density and gravitational pull. Section 6. Expanding our cosmic perspective, what Ui Scuti teaches us. The discovery of Ui Scuti has had a profound impact on our understanding of the universe. It has shown us that stars can exist on scales that we previously thought impossible. UI Scuti has also helped us to refine our models of stellar evolution. By studying stars like UI Scuti, we can gain a better understanding of how stars are born, how they live, and how they eventually die. Furthermore, UI Scuti reminds us of the vastness and diversity of the cosmos. It challenges us to think beyond our own solar system and to consider the incredible range of objects and phenomena that exist in the universe. Section 7. The search continues. Are there even larger giants lurking? While UI Scuti currently holds the title of the largest known star, the search for even larger giants continues. Astronomers are constantly scanning the skies. They are using increasingly powerful telescopes to probe the depths of the universe. It's entirely possible that somewhere out there, shrouded in dust and gas, lies a star even more massive and awe-inspiring than UI Scuti. The discovery of such a star would undoubtedly revolutionize our understanding of stellar evolution and the limits of what's possible in the cosmos. Section 8. The future of stellar observation, unraveling the mysteries of distant suns. As technology advances, so too does our ability to study the universe around us. Next-generation telescopes, both on the ground and in space, promise to deliver even more detailed observations of distant stars. These telescopes will allow us to study the atmospheres of these stars, analyze their chemical compositions, and gain a deeper understanding of the processes that drive their evolution. We may one day be able to directly image the surfaces of stars like UI Scuti, revealing details about their structure and behavior that are currently hidden from view. Section 9. Conclusion, a universe of wonder. The universe is a place of endless wonder and discovery. UI Scuti, a star of truly colossal proportions, stands as a testament to the incredible scale and diversity of the cosmos. As we continue to explore the universe, we can be certain that we'll encounter even more awe-inspiring objects and phenomena that will challenge our understanding and ignite our imaginations. From the smallest subatomic particles to the largest structures in the universe, there's always something new to discover. UI Scuti is just one small piece of the cosmic puzzle, but its discovery has opened our eyes to the vast possibilities that lie hidden in the depths of space.